This video is going to walk through how to set up the development environment so you can get working on Gallery Gateway, followed by a brief design walkthrough to tell you a little bit about how everything works. To start, let's do the setup for the development environment. We're going to start with the backend and then go to the front end. On the right hand of my screen, you'll see that I have this terminal open to my local version of Gallery Gateway. And on the left hand, I have the GitHub open. This right here is happening in the virtual machine, which we will be providing to you guys. So some of these setup steps may not need to occur if you're using our virtual machine, because we'll have already done them for you. If you're setting up your own working environment, then you'll have to do them yourself. To start, let's go to the backend in the repository, and we'll see these installation steps. We're going to follow those through and explain a little bit what they're doing. Once we're in the backend, we can run npm install. This is one of those steps that should only have to happen once. And what that's going to do is build all the project dependencies out. If you are adding dependencies to your project, you might need to run it more than once. This may also take a little longer the first time you run it than it's taking right here, because I've already installed the project and I'm just running through it again. Now that npm install has finished, we can copy over some of the environment variables to get started on setting up our authentication. The next script to run is the key generation script, which you run with that npm run command there. And now that those are run, we can set up our database by moving to the Docker folder. All of the Docker stuff is in this Docker folder, and that's where we'll run the command to start Docker using docker compose up -d. That -d is a flag that runs Docker headlessly, so we can keep using this terminal window. The companion command there is docker compose down, where if you're having a problem with your database and need a hard reset, you can run down and then bring it up again, and it will reset your database. Now that Docker is running, we're going to need to copy some certifications into our repository. There's a link to the file we need in the README right there. I have the window open here. You can just copy the whole thing and paste it in. And we need to be absolutely sure that the file that this is in is named idp_cert.pen. And save that. Now that that's in there, we can run the database migrations. These may not, migrate. These may not have to run every single time, but anytime that you change the structure of the database, you will need to rerun the migrate. Running the migrate actually does the work that changes the structure of the database. So if you add a table, then you'll need to run migrate. This command will occasionally fail with a timeout command, timeout code. If that occurs, you can just run it again. It's not an actual issue. Here we can see it building our database. And next we can run the database seeding script, which is called seed. And this will put in some basic default data like our users and a show for the Gallery Gateway Honors show. A show for the show portion of the tool. If this one fails in the middle, you may need to rerun migration and seeds because the seeding does not roll back as cleanly. Now all the setup is done for the back end of the project, and we can run start to get our project going. Once this pops up, we know everything's okay. Now that the back end is set up, we can start on the front end of the system, which I'll be doing in a new terminal. The front end can be run from the front end subdirectory, and we will go there in the GitHub repository as well. The front end requires npm and Node, as well as another package manager called Yarn. And the setup is a little simpler. I'm going to run yarn install, which will install the front end dependencies. Mine ran really quickly since I've already done it. Yours might run a little slower the first time. And we're going to run yarn start to start our program. We should see it pop up in just a second with the information about the front-end web server. There will be a few warnings that are happening in the dependencies that we can just ignore. Now that that's popped up, we can go to localhost 5000, where we'll see Gallery Gateway. Looked like it had me authenticated as a user that didn't exist anymore because I had run it before. This should be what pops up when you see it, the login screens. And we can click Login. It'll bring us to this authentication screen that runs only in the development environment as a replacement for the Shibboleth SSO login. The usernames and passwords it asks for here are available if you look in our project in the auth sources PHP folder under Docker and the test SAML IDP, where you can see the user and user password. And that will authenticate you into Gallery Gateway. The first user is an administrator. The second, third, fourth, and fifth are judges, and 6, 7, and 8 are students. So if you're testing features that are dependent on the type of user, those would be the authentications that you want to use. The final thing to show you will be the deployment for production. If we go to the README on the top level of Gallery Gateway's repository, you can find some more instructions about what's required. There is no Docker on the production deployment, so MySQL will need to be installed. And there are also a couple other dependencies that will need to be set up on the server which you are deploying from. The server that Gallery Gateway is currently running on has most of these installed already, so unless you add something new, it should be good to go. To deploy, what you're going to want to do is go to the deploy subdirectory and find this deploy.sh script. You can see it's in the version of the repository right here. And what you are going to do is download that script onto the server which you are deploying from and run it with this command where get URL is the download zip link to whichever branch of the repository you are running from. So you can find that in the cloner download. It'll have this download zip. You can copy that whole link. And once you have that and run the command, it should perform all of the production deployment for you.
So at this point in the video, we'll be going over our basic system design. This will be separated into our API powered by GraphQL, our front-end design, our back-end design, and then we'll go into our database design a little bit. Starting with our GraphQL API, this API is touched by most aspects of the system, so it should be useful for understanding the rest of the interactions. We can see here in schema.js some of the GraphQL definitions. GraphQL separates database operations into two types, queries and mutations, with queries being your basic read operations, anything that doesn't manipulate the database, while mutations are your create, update, and delete operations, anything that would manipulate the database. The available queries and mutations with their parameters and return types are defined here in schema.js. Each of these functions is then defined in the resolvers directory in the backend. These API functions are linked to the backend resolver function of the same name through the file exports defined in index.js in resolvers. We'll get more into that later when we talk about the backend. But here in schema.js, you can see some of the GraphQL type definitions. These type definitions are separated as types and inputs, with inputs being your input parameters for your mutations, things that are going to be changed, and types being your return types for both queries and mutations. Going into the front end here in admin mutations, create show.graphql. Again, we'll go more into the directory structure of the front end later in the video. But here we see a function definition referencing again the same functions that are defined in schema.js. In the case of the front end, the functions are separated into two directories, mutations and queries, and each function will more or less have its own file. In these files we can see that it looks like there are two function definitions. The first of these function definitions is the definition for the front end. This is the function that's called from within the front end in order to make the call to the backend API and eventually get the data from the database. Notice that the input here is still a GraphQL type, but it will be passed in as a JavaScript object reflecting the same structure as that GraphQL type. The second function is the actual call to the backend API. So this function does need to have the same name as the function defined in the backend, while this function doesn't necessarily need to have the same name, but typically they're both given the same name just for ease of understanding and ease of use. Then we see these values under the second function. These are the returned properties. What that means is that when the call is made to the backend through the GraphQL API, you'll have this return type, which is defined in the backend, which contains several properties, these properties among them. But in the front end, we define which properties we actually want. This allows for an added layer of security, as different user types can be passed different amounts of information from the same query. So if I didn't want the user making this query to know the judging start date of this particular show, I can just remove that and even though judging start date is passed by the backend function, it will not go through to the front end simply because that return type is not defined here. As you can see here in the admin shows query GraphQL file, if there are nested objects within the return type, the desired properties from within the nested object must also be specified. For example, here a judge has more properties than just a username, but when querying which judges are responsible for judging a show, username is all you want passed back to you, and so that's all that gets specified. The return types in general are a little more important for queries than for mutations because this is what you're querying. This is the only thing you'll get back. But mutations can still pass return types if the backend mutation function returns something. You can use that for validation of changed data. So this concludes our discussion of the GraphQL API. We'll go a little more into how the backend and frontend can access that API later in the video. If you'd like to know more about GraphQL, there is information online about how you can form some of these queries. At this point, we'll be going into some of the front-end design of this system. The front end is React Redux based. If you're not familiar with these technologies, some introductory readings and links are found in the README. There are also plenty of helpful resources online. They're both very well documented. The source directory in the front end is divided into 3 different user groups, including admins, judges, students, as well as a shared directory for shared components. These are the important directories that we'll be looking at. These directories each contain an actions and reducers file which handles some caching information. Then there's also the mutations and queries directory, which we briefly went over earlier. These contain the front-end GraphQL files that you might be familiar with by now for the queries and mutations that each user type can perform. So an admin will have different available queries and mutations than a student, for example. Then there's the page.js file. This is typically where you'd start if you're going to make a new page for the system. There's, again, one of these for each of the admin, judge, and student types. And this is where the routes from the different URLs to various components are held. High-level containers for these pages are all held in the pages directory. These serve as wrappers for underlying components, as you can see, with basic header information and usually not much more. But as you can see here in the student submit page, the high-level page will sometimes route to further subpages based on, again, the URL. Additionally, the page routing can handle URL parameters. As you see here in view show, it will take this ID parameter. The URL parameters are denoted by a colon in the path definition. Then from within the file in the pages directory, that parameter can be accessed through the ownProps object. Now we'll get to 2 of the most utilized directories on our front end, being components and containers. The containers directory contains API calls used to pass information from the backend onto the components. The components then contain most of the data regarding the appearance of the page and populate the fields on the page with information passed on by the container. This allows for components to be reused with multiple different containers. For example, our selector card component uses this render buttons function. The function definition is passed on by the container and will change which buttons are displayed. Therefore, the managed scholarships container can call it and pass in an update and delete button, and when this function is called, an update and delete button will be created and added to the component. Meanwhile, a student's view scholarship container, which doesn't supply these buttons, will just have no buttons and allow the students to view the container without having any options available to them. We're going to step through the Create Show page in the admin directory to demonstrate the flow of this functionality through the whole front end. First of all, we can see in page.js the Show New path is set to route to the Create Show page that's found in the Pages directory. We can then see that that page is a simple wrapper, putting a header over the more significant create show form container. In the create show container, we'll see a few functions that we can go over. First, there's this map dispatch to props function. What this function does is define two functions that can be used to reroute the user. The done function will reroute the user back to the main shows page when it gets called, while the handle error function can be used to pop up an error message from within the page. Both of these functions will be available to be called from within the underlying component that this container wraps around. Next, we see this compose function. This looks a little confusing, but what it does is it will pass the mapped properties from map dispatch to props, as well as the results of this GraphQL API call, into the underlying create show form component. Within that component, these properties will then be available all inside of a JavaScript object called props. The API call makes use of the create show mutation defined in the GraphQL API. I'm going to go over the specifics of this function because some of it can be a little confusing. First, the create show mutation is a direct reference to the GraphQL API function defined in queries shows GraphQL. The next line defines a props object, which contains all the properties that will be passed into the container from this API call. In this case, the only property being passed is the create function. The mutate variable passed into the function is the create show function from the API. The create function has a parameter show. This parameter will be fed in by the component when the create function is called from within the component. Using this parameter passed in by the component, create calls mutate, which is the function from the API, and it will populate the variables of that function based on the variables provided by the component. Then we have the refetch queries option. This is used to tell the API that the shows query has now been changed. The data that that query will receive has now been changed within the database. So anywhere that that query is used, GraphQL needs to refetch that query rather than using cached information. This API call is an example of a GraphQL mutation. GraphQL queries will look a little different, so we'll take a look at another example of a container just to go over the differences. This is an example of a query rather than a mutation. Here, the result of the query is directly added as one of the props through this shows variable rather than passing in the entire function as a prop. If a query takes parameters, then they're passed in through this variables option, as you can see here. Going back to the create shows page, we're now going to take a look at the component, which, if you recall, manages most of the actual front-end appearance. Since it contains all of the HTML, this page is rather large, but I'll step through some of the more important pieces. This is the render function, which, if you've used React 4, you'll know returns the HTML information for the page. Notice these constants defined here are some of the props that were passed in by the container, including the done function, and the create function, which is the call to the API. Below this is a formic form. This contains validation information to make sure the form was filled out correctly, as well as this onSubmit function, which calls that create function, the API call. And as long as that was successful, as long as the mutation was successful within the database, it will then call the done function to reroute back to the home page. Alternatively, if it fails, it will call that handle error function, which is the third function that was passed in by the container. The rest of the page is HTML that describes the look of the form itself. That concludes our front-end design walkthrough. We'll next take a look at the back end, and we'll see how some of this data is acquired from the database through the back end. The back end runs on JavaScript with several node packages included. Most importantly, it uses a Sequelize library to handle database interactions. The most important backend directories are the models directory and the resolvers directory. Both of these handle the database interactions in the backend. The files in the models directory contain information correlating database tables to JavaScript objects. These files should, for the most part, correlate one-to-one with the database tables themselves. The Sequelize define method describes the columns of the table, each having a data type as well as any other MySQL properties that might be applied to the column, including default values and the like. Foreign keys can also be defined through these objects, as you can see in the student username section of the entries table. Foreign key relations should then be reflected in index.js using the belongs to function on one-to-many relations, or the belongs to many function in the case of many-to-many relations. A linking table will be defined for the many-to-many relations using the through property. The files in the resolvers directory then handle the database operations that are defined through the API, separated into mutations directory and a queries directory. These functions take args, passed through the API, and a request that includes user authentication information. They then use sequelize operations, including find, create, update, to get objects from the database and manipulate them. The types directory contains information needed for the resolvers to access linked tables. For example, the show judges property needs to query its linked users table to include a list of judges in the result for a show query. Last in the resolvers directory is the index.js file. This provides exports so that the functions within the resolvers directory are visible to the API through the schema.js file that we mentioned earlier in our API discussion. If you remember correctly, functions in any of the resolvers files should have an equivalent function defined in the schema.js API file. That concludes our brief discussion of the backend. Obviously there's a lot more to it, but most of it is fairly simple. The most important part is understanding how these models and resolvers interact with both the database and the API file. Lastly, we have the database itself. The database is created using these migrations files found under the DB directory in the backend. The database is set up through sequelize, so you'll notice that the migrations files look pretty similar to the backend models. Each migration contains both an up function and a down function. The up function performs needed changes to the database, such as adding and updating tables. The down function should be the inverse of the up function, so that sequelize can roll back its database changes if an operation fails. The migrations are all time-stamped and contain a complete history of all changes in the database, so that older versions of the database can be correctly brought up to date by these migrations. For this reason, it's important not to edit existing migrations. Instead, you'll need to create new migrations that apply the desired changes to the table you wish to change. For example, if I wanted to add a column to shows, I wouldn't change this shows file. I would instead add a new file that runs an add column operation on the shows table. Obviously, having a down function that would remove that same column. A skeleton of a new migration with the proper timestamp can be generated by calling the sequelize command from whichever library it's held in, followed by the command migration generate with a name argument for your skeleton. Notice that this new empty migration has popped up where I can add tables or alter existing tables. And this will run last in the sequence of migrations to ensure that everything's executed in the correct order. This concludes our design walkthrough. For more detailed information, you can check out our technical spec and some of the UML diagrams that are provided in our documentation repository along with this video.